Okay, this was a question that was asked over email. It's from section 3.4, and it's number 47. And they give you this function right here, and the directions, they ask you to find all zeros. And when they say find all zeros, that means that they want the real zeros and also the imaginary zeros. Okay, so the first thing that we need to do is a PQ list for this thing. So the P is always going to be associated with our constant. So our P list here, we're thinking about the different factors of the number 20. So we have plus or minus 20, plus or minus 10, plus or minus 5, 4, 2, and also 1. Okay, so that would be our list there for trying to get this so you guys can see it a little better. That doesn't work. I don't know what's up with the glare today. And then our list for Q are just the different factors of 13. So we have basically plus or minus 1 and plus or minus 13. Okay. All right, so what we're going to do is assemble the P over Q list, which is taking all of these numbers and dividing them by each of these numbers. So it's going to be a relatively big list. So our P over Q list is going to be, if I take 20 divided by 1 and 13, divided by 1, it's just going to give me 20. And divided by 13, I'm going to get 20 over 13. We're going to do that for each of the rest of these, 10, 5, 4, 2, and 1. So it'll be plus or minus 10, plus or minus 10 thirteenths, plus or minus 5, plus or minus 5 thirteenths, plus or minus 4, plus or minus 4 thirteenths, plus or minus 2, plus or minus 2 thirteenths, plus or minus 1, and plus or minus 1 13ths. Okay, so this list gives me all of the possible real zeros that I could have out of this. So if I'm going to have a real zero, it's going to come from this list right here. Okay. All right, so we can use synthetic division to basically try each of these, but that's a whole lot of things to try. So I think what we should do is use Descartes' rule of signs to see if we can eliminate any of these. Okay, and so if I look at my original function, I notice that there's 1 sign change here, 2, and 3. So that means that I would have basically, I have 3 or 1 positive real zeros. And that's according to Descartes' rule of signs. Okay, if I want to evaluate f of negative x, then I can find out how many possible negative zeros I have. So if I plug in negative x, everywhere there's an x, and then I evaluate it, then I can take a look at those sign changes. Okay, so if I take a negative x and I cube it, that's going to be a negative number. So that'll be a negative 13 x cubed. Negative x and you square it, any negative that you square will become positive. So that's not going to give us any kind of a sign change out front. It'll just stay the way it is. This is going to become a negative 268x and then minus 20. So you notice that f of negative x here has no sign changes. They're all negative. Okay, so what that tells me is that there are no negative real zeros. And the reason that that is helpful is because that actually allows me to eliminate half of my list here. I have all these plus or minuses, and I don't have to worry about any negative values being real zeros here, because that's what this is telling me. So I should shoot for the positives. Okay, and I did this ahead of time. You could take a long time here doing the synthetic division on all of these, but basically, if you try 1/13, a positive 1/13, it's going to work. Okay, and the way that we synthetically divide, so I'm going to take each of these numbers here, 13, negative 105, the 268, and the negative 20, and I'm just going to use the numbers without the variables in them. And the process of synthetic division is to bring down this number. So I bring down my 13, and then I'm going to take this number 13 times the 1/13. Okay, so 13 times 1/13 is a positive 1, and that 1's going to go right here. Okay, and then I'm going to add these two. So negative 105 and 1, that's a negative 104. and then I do this all over again. Negative 104 times 1/13 is a negative 8. Okay, and then I add, so I get a positive 260. 260 times 1/13 is positive 20. And then when I add those and I get a 0, this right here is what tells me that 1/13 is one of my zeros. It's also going to allow me to factor my original function, because if you take a look at your original function, and it's this, and we need to be able to factor it in order to solve. We could go through the, well, no, we need to be able to factor it. So what this tells me right here is that f of x now factors into x minus 1/13, and that's one of our factors, and my depressed equation is 13x squared minus 104x and plus 260. Notice that the depressed equation, each of my starting exponent here is one less than the exponent on my original function. Okay. The other thing is, the reason this is x minus 1/13 is because if I were to set this to 0, then I would get a positive 1/13 out. So positive 1/13 is a 0. That positive 1/13 comes from an x minus 1/13 factor. Okay. Now the question on email was basically, how do I solve that? And what we're going to have to do first of all is we can factor out a common factor of 13. So pull out the 13, you're going to be left with x squared minus 8x and then plus 20. Okay. What we would want to do is we'd want to take this, and since it doesn't factor, we would actually want to stick it into the quadratic formula. Okay, so the a is 1 here, a is the coefficient of our x squared, b is negative 8, and c is the positive 20. Okay, so as I stick those in to my quadratic formula, it's negative b, so the opposite of negative 8, plus or minus the square root of b squared, so negative 8 squared, minus 4 times a is 1, c is 20, and that's all over 2a. Okay, so that's going to give me positive 8 plus or minus, this is the square root of 64 minus 80, all over 2, which is 8 plus or minus, this is the square root of a negative 16. Square root of a negative number means that we're going to be looking at an imaginary number for this, complex number overall. So this will be 8 plus or minus 4i over 2. The 4 is coming from the square root of 16. The I is coming from the negative. Okay, and then if I divide 2 into each of those, I'm going to get 4 plus or minus 2i. All right, so here's two of my zeros, 4 plus 2i and 4 minus 2i, and then the x equals 1/13 is another one of my zeros. Notice a couple of things. Notice that the fact that this was a third power told me that I was going to have 3 zeros total, and I did find 3 zeros, 2 there and 1 there. And this fits my Descartes rule of signs. I was supposed to have either 3 or 1 positive real zeros. I did get 1 positive real zero. I was supposed to get no negative real zeros, and there's no negative real zeros. There are some complex zeros. Okay.